So I will be talking about infinite ignorance today. So this is the motivating question for this talk. How should we make ethical decisions in a world that is potentially infinite when we can only affect a finite part of it? This is the motivating question for the whole talk. So I'm going to talk about some thoughts in philosophy on this matter, and then some thoughts in econ on this matter, and then I'll go on from there. So here are the thoughts in philosophy on this matter. So it is well known that most ethical theories break down when applied to this question. In fact, due to this Bostrom 2011 paper, what is infinite paralysis? Suppose that every feasible action causes a finite change in value. If there is any positive probability that the universe contains infinite moral value, then we should be morally indifferent among all our feasible actions. This is infinite paralysis. We're paralyzed by the fact that the universe might be, in fact, infinite. The intuition for this paralysis is quite simple. So if we first assign moral values to universes, and then we evaluate probability distributions over universes by their expected moral value, then the expected moral value of any probability distribution, which places positive probability on universes which have an infinite moral value, is going to itself be infinite or undefined. This is the straightforward intuition for infinite paralysis. So making a mere finite change to an infinite expected moral value changes nothing. Okay, so now let's look at the econ thoughts. So here's a standard equation that we often see in economics. We're going to evaluate the value of some stream of x, where x can be anything, consumption, for example, but also other things that you might care about. And what we're going to do is we're going to take the value to each agent at each generation, u of x, at each point in time, and then we're going to sum it across time, but we're going to discount it according to delta to the t. So if we have a positive pure rate of time preference, which is then a temporally infinite universe, so a universe that extends into infinity temporally, causes no issues, because we're just going to discount the utility of the people further and further out. Though this won't solve issues if the universe is spatially infinite. However, many, including me, believe that weighing people's welfare less the more distant they are from us in time or space seems morally inadmissible. So we should not have a positive pure rate of time preference. So if we instead use a zero rate of pure time preference, then this discount factor, delta to the t, must instead represent extinction risk. Okay? So before we could have interpreted this as a pure rate of time preference, but I want to rule that out. And so now if we still have a delta t in our model, the interpretation now must be that delta to the t represents extinction risk. So the probability that a generation is in fact existing because it survives until that point. This means that in this model, the world is finite with probability 1. So if we write down this model and interpret delta to the t as extinction, the probability that you're still surviving at that generation, then this model assumes a finite world, and hence it's not thinking about the question I initially posed, which is what happens if the world is potentially infinite. So then the question is, what happens if we have a universe that is in fact possibly infinite? So here's a very simple way of writing this down if you would like to. So on the left, we have p, so the p probability that the world is finite, and then I've generalized the discount factor to be a survival function that I'm assuming is such that this sum converges. So I'm calling it S finite. So there's some probability that the world is such that the survival curve admits a convergent sum. With probability 1 minus p, the survival curve is a different one, which doesn't admit a converging sum. In particular, the object on the right diverges to infinity. And so this is one way of capturing, with probability p, the world is finite. With probability 1 minus p, the world is infinite. And a simple example of this would be that on the left, we have the standard model, and on the right, I just removed the discount factor completely. Okay, so this v is undefined for most x. because of the right term being undefined. And so, in summary, economists generally do not consider models with a potentially infinite universe. They consider just the left term. And if they did, by considering both terms, the standard approach wouldn't work. In other words, this B function is undefined. Okay, so that's the synopsis of some views in philosophy and economics on this question. So now I would like to go back to foundations. So in both philosophy and economics, why would we write it this way? So this is a more abstract version of the thing that I just written, and it applies to both the philosophy and econ approaches. The value of something that we care about, some stream of x, is going to be p times a well-defined sum. So this is the probability that the universe is finite, plus 1 minus p, the probability that the world is infinite, times an undefined sum. And then we're going to take this convex combination between a well-defined sum and an undefined sum. So why would we write it that way? In particular, how did we decide that what we care about can be measured as an expectation over some numeric utility assigned to states of affairs? How did we decide that thing that grounded that we could write it this way? And moreover, does this foundation, whatever that foundation is, say that we should take expectations even over undefined numbers, which is what we're doing in this expression? So in my view, the most sensible and convincing foundation for expected utility is the von Neumann-Morgenstern axioms. But these axioms say nothing about coherent preferences in a potentially infinite universe. The axioms themselves imply that the world is finite. In particular, the continuity axiom implies that the world that we're considering is finite. And hence, in my view, the logic underpinning infinite paralysis, the thing I mentioned at the start, is based on theories, for example, expected utility, which are being applied outside the domain in which they are grounded. So expected utility is grounded in finite worlds, in my view, not grounded in infinite worlds, yet we are applying them in infinite worlds anyway. Right, so expected utility theory was never supposed to, at least in my opinion, apply to potentially infinite worlds. Okay, so in this paper, I'm going to go back to the beginning, so to say, and I'm going to formulate that we have a potentially infinite world from the start. And then I'm going to build the theory up from there, in the very same way that von Neumann-Morgenstern did in a finite world. The result of this exercise is what I call infinite ignorance, the title of this talk. It says the following. Suppose every feasible action causes a finite change in value. If there is any positive probability that the universe contains finite moral value, if there's any chance that the world is finite, then we should evaluate our feasible actions conditional on the universe containing finite moral value, conditional on the world being finite. So if there's any chance the world is finite, we should evaluate our actions conditional on the world, in fact, being finite. This is the result that I'll derive for the rest of the talk. So said in more basic words, saving a life is clearly good in a finite world, but it's not clearly good in a potentially infinite world, at least at the outset. Infinite ignorance says that if it's good in a finite world, it's good in a potentially infinite world too. Okay, so now this is just me putting infinite paralysis and infinite ignorance side by side, and what I've done is I've highlighted the differences. Okay, so in infinite paralysis, it says if there's any positive probability the universe contains infinite moral value, then we should be morally indifferent across all actions. This is, for example, justified by expected utility theory, which I think is being applied outside the domain in which it's grounded. But then if we go back to basics and build things up from scratch, we get infinite ignorance, which says that if there's any positive probability that the universe contains finite moral value, then we should evaluate our feasible actions conditional on the universe containing finite moral value. Okay. So just applying this infinite ignorance result to the expression I had earlier, it implies that we can evaluate x, whatever it is that we're thinking about, by just the left side. So conditioning on the fact that the universe is finite and ignoring the thing on the right, which is undefined. So the way in which von Neumann-Morgenstern axioms don't allow for an infinite world is a bit subtle and involves thinking through we're not thinking about summing across generations in VNM. And we can talk more later, but the claim would be that if you think about VNM applied to infinite ethics in the appropriate way, then you realize that the continuity axiom is effectively ruling out worlds that have infinite value suitably defined. So a quick note before we begin. In my view, I think ranking surely infinite universes is supremely difficult, confusing, and paradoxical. The more I thought about it, the more I think this is the case. So approaches model universes by cutting them into pieces, assigning values to the pieces, and then lining up the pieces into an infinite sequence. So we have an infinite universe, we cut it into pieces, we assign values to those pieces, moral values, and then we line up the pieces into an infinite sequence. And then they impose axioms on orderings over the space of infinite sequences of real numbers, where the infinite sequences are supposed to represent the universe that they cut into pieces. One common axiom in this domain is Pareto, which says that if each element of sequence A is strictly greater than its corresponding element in sequence B, then A is strictly better than B. However, in infinite domains, this Pareto axiom changes how it ranks universes depending on how it is that you cut the universe into pieces, which is not true in finite domains. In finite domains, this is all, doesn't matter how you cut it into pieces. So in particular, universe A could Pareto dominate universe B under one way of segmenting the universe, and then the very same universe, A, could be Pareto dominated by universe B under a different way of segmenting the universe, a different way of cutting it into pieces. This is true if one way of segmenting the universe is by people's lives, and then the other way is segmenting the universe by blocks of space-time. That's one way in which this could arise. But even if we just agree that we should cut the universe up by space-time, it's also true that there's different ways of cutting it up by space-time, so drawing different grids could have the same result, which is that Pareto in one segmentation could say A dominates B, and then in the other segmentation say that B dominates A. In my view, I don't think how we construct segmentations of universes, including within spacetime, should affect how we morally rank them. And hence, in my view, the approach of modeling universes as an infinite sequence and then imposing Pareto is worrying for this reason. In this analysis, I'm neither going to segment the universe into infinitely many pieces, nor am I going to impose Pareto. Cool. That was a quick note, and now into the model. Let omega be a set of complete histories of the universe across all of space-time, past and future. So omega specifies everything about the universe from over all of time. Let delta omega be the set of all probability distributions on omega. Each action that we take is going to give rise to a probability distribution over histories of the universe. So when I go outside and I throw a ball in the air, that induces a probability distribution over possible universes. And hence, I'm going to call these distributions actions. Okay, so a distribution over states of the world is an action. And I'm going to label them usually by P and Q. Let squiggle be a transitive and possibly incomplete relation on delta omega, reflecting the moral preferences that a decision maker feels confident in. Okay. So for some actions, I might be confident that the induced probability distribution over states is preferred to another, in which case it would have this relation. And I'm going to call the squiggle, which again is transitive but maybe incomplete, the natural preference. This is our natural preference. This is the preference that a decision maker feels confident in. Let squiggle star, by contrast, again, it's transitive and possibly incomplete, but this relation reflects the moral idealized preference that the decision maker aspires to, but may presently be ignorant of. So this is like the true moral preference known only to God. So I'm going to call this the divine preference. Okay, so this is like the true moral ranking between actions, which is also potentially incomplete, which we don't know, but we're aspiring to know. Okay? So the divine preference. So the first axiom states that squiggle is compatible with squiggle star, i.e. anything that we're confident in is right. So if we're confident that saving a life is good in finite worlds, then the divine preference is also the case that saving a person is good in finite world. Okay, so we're not wrong about the things that we're confident in. The whole point of splitting this into two is that we might not know how to rank something, but maybe the divine preference does know. Okay. So now I'm going to decompose omega into two pieces, I and O. Intuitively, I is going to describe aspects of the universe that the actions under consideration can affect. So they're going to be thought of as inside our sphere of influence, which is where the I comes from, inside our sphere of influence. O is going to describe aspects of the universe that the actions under considerations cannot affect. So they are outside our sphere of influence. O. So what does it mean to be inside and outside our sphere of influence? So suppose I ask you how much you would bet on this event, the event that Donald Trump eats a Big Mac in the first week of 2025. So you might place some bets on this. Would your bet change if you take one action P versus another Q? You can see how it might, since your actions P and Q might predictably influence the chance that Donald Trump eats a Big Mac in 2025. And this is precisely what it means for aspects of the universe, this particular aspect, to be within your sphere of influence. Your bet may change upon taking different feasible actions. So that's what I take it to mean, that something is in your sphere of influence. It's that your bet on the event could change in principle when you take one of two different feasible actions. Now suppose I ask you how much you'd bet on the event an alien creature on a planet unreachable by light shone from Earth today, Dlanod Mert, eats a gibcam in the first week of 2025. Would your bet change given you take two different actions that you might be considering, like saving a life on Earth? You can see how it might not, since this planet is outside your future light cone, and that's what I'm going to take it to mean for an aspect of the universe to be outside your sphere of influence. That your bet on the aspect would never change upon taking any one of several different feasible actions. So all of your feasible actions induce the same beliefs about the event. That's what I take it to mean to be outside your sphere of influence. Okay, so formally, I'm going to represent all the stuff that we just discussed as follows. So I'm going to say that two actions P and Q have no ex ante effect on script O relative to each other if for any O that's a subset of the script O, the probability that O occurs is the same. So let's go through this in a sec. So this notation here is going to be important throughout the talk, so let's just briefly discuss what that means. So script I is the set of all possible things that could happen inside our sphere of influence. And O is a particular set of things that could happen outside our sphere of influence. And so when you take the Cartesian product of the two, you get an event, the set of histories for which anything occurs inside our sphere of influence, and a particular thing occurs outside our sphere of influence. And what this definition says is that two actions, P and Q, which are distributions over states, have no ex ante effect on things outside our sphere of influence if for any particular thing that could happen outside of our sphere of influence, the probability of that event, which is that particular thing happening outside our sphere of influence, combined with anything happening inside our sphere of influence, is the same across P and Q. So P and Q are two actions that induce the same beliefs about what happens outside our sphere of influence. Okay. So that's what's going to capture this idea that something is in fact outside our sphere of influence. If this thing is true, then the O is outside our sphere of influence. Right, so now I have to find what it means to be outside your sphere of influence. And by the way, just to give you a high-level sense of why I'm doing this, the stipulation at the beginning of this talk was to suppose that your actions have finite value. right? Is saying what happens when your actions have finite value, but the universe is potentially infinite. And basically what I'm doing is I'm formally defining what it means for your actions to have finite value. If you think that your actions have infinite value, then that's just a different question. And so what I'm saying here is if you think two actions have finite value, what it basically means is that they're limited in their effects, right? The effects are only finite. But we can talk more. Okay, so now a finite world is just a world which we are confident in evaluating in this model. So let O sub f, which I'm always going to color orange, I'm going to call it OF, be a set of aspects of the universe outside our causal sphere, such that when we condition on the event that anything happens inside our sphere, and this particular set of things happens outside of our sphere, we can confidently rank actions P and Q. So for example, IOF might be the event that there's just nobody outside our sphere of influence. So maybe the universe is infinite outside our sphere of influence, but there's just nothing there except rocks. That would be an event for which, when we condition on it, there's only finite many people, and hence we are fairly confident about what to do because the universe is effectively finite. But it could also be other things. It could be the event that there are less than 1 trillion people outside our sphere, or it could be, this is the one I like most, that there's just no sentient life outside our sphere. So that's a possibility. This is the set of all histories for which it's true that there is no sentient life outside our sphere of influence. And in those cases, for that event, we would be pretty sure about how to rank actions because the universe is finite. Okay. Formally, to capture what I said on the previous slide, I'm going to say that P and Q are comparable given OF if we know how to compare P and Q conditioning on the event of I times OF. Okay, so what this says is that if the things that are happening outside our sphere of influence are the things that we specified for which we understand how to rank things, so for example, there's no sentient life beyond our sphere, then conditioning on that event, we know how to rank P and Q. So it's either the case that P is weakly preferred to Q or the opposite. If that's true, I'm going to say that P and Q are comparable given OF. And this is what it means for OF to capture a finite universe. That's why I've labeled it F. OF captures finite universe. Even though the universe might actually be infinite, there's not infinite value in that universe. So this definition is what gives the OF like a justification for putting the F there. So OF represents the universes that are, in a sense, finite because we know how to rank conditioning on these events. Okay. So let O infinity be the rest of the things that could happen outside our sphere of influence. Okay. So OF is the things that happen outside our sphere of influence for which the universe is finite intuitively, and then O infinity is everything else. So intuitively, OF captures the finite worlds, and O infinity captures the infinite world. Specifically, let's think of IOF as the worlds in which sentient matter only occupies finite space and time, and the rest of the possibly infinite universe is filled with non-sentient matter. And then let's think of O infinity as the rest of it. So now I get to the most important principle in the talk, which is something I call cautious ignorance. So it states the following. Given any two actions P and Q, which are comparable given OF, which is just to say that OF is a finite universe, that we understand what to do in that universe, a decision maker is cautiously ignorant about P and Q given the rest of the universes that we don't know what to do about if the following holds. If P is weakly better than Q in the finite worlds where we understand what to do, then it should be the case that the divine preference is not strictly the opposite in the worlds that are infinite. So cautious ignorance reflects the idea that if a decision maker is confident about how to morally rank two actions P and Q given finite worlds, then although she may still be uncertain about how to rank P and Q given, for example, there are infinitely many sentient beings out there, she should be confident that her preference shouldn't strictly flip. So she is not completely ignorant about the divine preference, but rather cautiously ignorant of it. So here's an example of that. So suppose that we have these two actions. The left one says that there are going to be 3 happy people within our sphere of influence, and then outside our sphere of influence, OF, distant galaxies, there turn out to be 5 happy people. And notice that on both sides of this, so no matter which action we take, there are only 5 happy people out there, which is what it needs to be, because I'm stipulating that OF, anything in O, rather, is something that we can't affect. Okay, so they can't be different on each side. The right act only has 2 people inside our sphere of influence and then 5 people out. So suppose we say that the left one is better than the right. So saving a life on the left is preferred to not saving a life when there are only finitely many happy people in the universe outside our sphere of influence. Cautious ignorance says that then it is not the case that if instead outside of our sphere of influence there are infinitely many happy sentient beings, it's not the case that the divine preference is that saving a life is strictly worse than not saving a life. Okay? So it could be, so another way of saying this is that if saving a life is good in finite worlds, and we know that, then it's possible that saving a life is still good in an infinite world. It's also possible that saving a life is just morally indifferent to not saving a life in infinite worlds. And it's also possible that saving a life and not saving a life is incomparable in infinite worlds. But the one thing we rule out is that saving a life is not strictly worse than not saving a life in infinite worlds. Okay? I'm just ruling out that one thing. And I call this cautious ignorance. Okay? The last axiom is independence. So this is just von Neumann Morgenstern applied to the divine preference. So I'm saying that the true preference, the divine preference, should respect independence. This is the independence axiom. Many of you have probably seen it before. I'll just go through a story version of it briefly. So suppose that you tell me that you'd like me to get you an apple from the grocery store, but if there are no apples, you'd like me to get you a banana. What that means is you're telling me that you like an apple better than a banana. If both are available, please get me an apple, but if the apple's not available, I'm happy with a banana. So apple's better than banana. But now suppose I tell you there's a chance that the store is closed, in which case I won't be able to get you anything at all. If you were to still tell me the same instructions, which is like, okay, if the store is open, please get me an apple, and if not, get me a banana, then what you would be communicating is this preference, which is that you prefer the lottery on the left to the lottery on the right. The lottery on the left is alpha probability that you get an apple when the store is open, 1 minus alpha, you get nothing when it's closed. You prefer that to a lottery of getting a banana with alpha probability or nothing with 1 minus alpha. So does your preference about what I should get you when the store is open depend on the probability that the store is closed? The independence axiom says it does not. Okay? So the probability that the store is closed shouldn't depend on, or your instructions to me shouldn't change with different probabilities that the store is closed. In all of these cases, you just like an apple better than a banana, and you'll give me the same conditional instructions. That's what independence is saying. Okay, so now we're ready for the propositions. So suppose axiom 1, compatibility, which is to say that our natural preference doesn't get it wrong, and axiom 2, independence, on the divine preference hold. Then for any 2 actions P and Q, if P and Q have no effect on O, this is what grants us the ability to interpret O as being outside of our sphere of influence, and P and Q are comparable given OF, this is what grants us the interpretation that OF is capturing what it means for the universe to have finite value. And we are cautiously ignorant about P and Q given O infinity, which is the thing I had a few slides ago, which is to say that conditioning on the finite worlds where we understand how to rank P and Q, when then thinking about how to rank P and Q, conditioning on the thing we don't know, O infinity, we allow ourselves to have the same preference as P P and Q for conditioning on finite worlds, or indifference, or incomparability, but not a strict flip, where suddenly saving a life went from being good to being bad just because we changed what's happening outside of our sphere of influence. Okay, that's the if, and then the result. It said if all of these things hold, then if P is better than Q in finite worlds, then it's either the case that P is the overall action without conditioning on anything is strictly preferred to Q in the divine preference, matching our preference conditioning on finite worlds, or they're incomparable. And then likewise for indifference. If it's true that conditioning on a finite world where we understand how to do things, P and Q are morally indifferent, then the divine preference also ranks the overall actions without conditioning on finite worlds as indifferent, or they are incomparable. Okay, and now there's just one final step until we get to infinite ignorance. I call this axiom 3, permissibility dominance. If some actions are surely permissible, so we know they're permissible, and others may or may not be permissible, so we haven't quite figured out if they're permissible or not, a decision maker should default to the actions which are surely permissible. Okay. So if you know that A is permissible for sure, and that B may or may not be permissible, then this axiom says that we should just choose A, because it's guaranteed to be permissible, whereas B, we're not sure. And so denote the relation that respects permissibility dominance by squiggle 0. So this is like the from the vantage point on Earth where we don't actually know the squiggle star. So combining the previous result with this axiom gets us the following. So suppose axioms 1 and 2 just as before, and now adding on 3. Then the same if. So if all of these things being, then we get the infinite ignorance result, which is that from our vantage point, P is better than Q if and only if P is better than Q, conditioning on the world being finite. This is just adding this permissibility dominance to this result to remove the incomparability. Because here it says that, for example, P is either strictly better than Q or they're incomparable. And then when you add axiom 3, it's just safest to choose P and not Q in that case. Because if you choose Q, it's either incomparable or it's worse. And if you choose P, it's either incomparable or it's better. Okay, so that's our result. So in words, when comparing two actions P and Q in a potentially infinite universe, it suffices to compare P and Q conditioning on the world being finite, in which case we can use our standard intuitions about finite worlds to evaluate P and Q. And then we can just generalize that up to the actual state of affairs, which is that there's some probability that the universe is infinite. I'll take questions. Okay, so I have like just a couple minutes, and so I'm going to go through the intuition, which is also the proof. It's very simple, and then I'll say one more thing, and then I'll be done. So here's the intuition / proof. If the universe is finite, suppose saving a life is strictly better than not saving a life, for the standard reasons that we feel comfortable evaluating this question in finite worlds. If the universe is infinite, saving a life must not be strictly worse than saving a life by cautious ignorance. Okay? So it's possible that it's strictly better, it's possible that it's morally indifferent, it's also possible that it's not comparable. But it's not possible that saving a life is strictly worse than not saving a life due to cautious ignorance. Now, suppose that there is some probability, positive probability, that the universe is in fact finite. And that means saving a life results in a strictly better universe than not saving a life with probability alpha in those finite worlds. And not a strictly worse universe with probability 1 minus alpha, that's in the infinite worlds. By independence, saving a life is either going to be strictly better than or incomparable to not saving a life. The independence axiom will imply that. And then by permissibility dominance, from our vantage point on Earth, where we don't actually know the divine preference, we don't know if it's strictly better or incomparable, then saving a life, again, from our point of view, is strictly better than not saving a life, because it's saving a life is either the strictly better thing or it's incomparable, whereas not saving a life is either the worst thing or not comparable. Okay. And so this is me just pasting this again. So the infinite paralysis result is that if there's any positive probability that the universe contains infinite moral value, then we're morally indifferent among all our actions. And then the infinite ignorance result, which I've just discussed at length, is that if there is any positive probability that the universe contains finite value, then we should evaluate our feasible actions conditional on the universe containing finite moral value. Okay. So now the final note. So we did this analysis with probabilities as a primitive, where actions were probability distributions over histories. So this is like a V&M framework where the primitive is a probability distribution over some space. It turns out that we may also do this analysis without probabilities as a primitive, where actions are sets of histories and subjective probabilities are merely a property of preferences over such actions. So probabilities in this framework are no longer part of the primitive, and this would be like a Volcker-Jeffrey framework. So it turns out that you can do both analyses completely in parallel, and that's what I've done in the paper. So both analyses, whether you do the V&M approach or the Volcker-Jeffrey approach, follow exactly the same logical structure and have the same exact conclusion, infinite ignorance. And I do both in the paper. But of course, today I only presented you the top one. And that's it. Thanks.